let's talk about blocking and non-blocking assignment and how we assign signals. So we've used several different ways, and now let's talk about specifically what the differences are. So there's a difference between blocking and non-blocking assignment. So this gets operator is a non-blocking assignment. That is the assignments, the outputs are assigned simultaneously with the others. On the other hand, this equals is a blocking assignment, so the assignment occurs in the order it appears in the file. So here's an example of a synchronizer. So we have two back-to-back flip-flops, and here we have our always underscore FF at pause edge clock, because we have two statements in here. We have a begin and an end. Those are like curly brackets in programming. And so we have begin, N1 gets D, and Q gets N1. So these get assigned, I can't draw this at the same time, but right, they get assigned at the same time. So N1 gets D, and Q gets N1 at the same time. However, in this blocking assignment, it almost looks the same. The only difference is these equal assignments versus the gets assignments, so these blocking assignments versus non-blocking. So in this one, N1 gets D, so here's this internal node N1, N1 gets D, so here's clock, so still at the pause edge of the clock, so that looks the same too. N1 gets D, and then Q gets N1. So it just says, okay, well, I guess Q and N1 are the same signal, and it synthesizes into a single flip-flop instead of two, because it's evaluated in a blocking way. This statement blocks essentially the following statements, so that this statement occurs first, and then that statement is evaluated second. And so it turns into a single flip-flop instead of what we wanted was two back-to-back flip-flops or a synchronizer. And so let's talk generally about signal assignment. Synchronous sequential logic, we're going to use always underscore FF at pause edge clock. And the gets operator or non-blocking assignment. And here's an example, our flip-flop. This is just the statement, not the entire module. For simple combinational logic, we're going to use what's called the continuous assignment statement, or the assign statement. That's what we've already been using. So here's a continuous assignment statement, assign y equals a and b. So it will continuously assign y these values when anything on the right side changes. But remember, actually what's happening is this is synthesizing into a gate, in this case an AND gate. For more complicated combinational logic, we can use the always com keyword and blocking assignment. So for example, within case statements or within if-else statements. Important thing is this is hardware. So we can assign a signal only in one block of logic. So if we have an always statement that assigns Q, for example, I can't then go somewhere else and say, oh, assign Q equals, who knows, 1 bit of 0. Well, now I've tried to assign Q two different things, right? I have Q here, and it's getting driven by this block of logic, and it's also now being driven by the second block of logic, and so we have contention. We can only assign Q. So this is where people get into trouble when they think of HDLs as a programming language. In programming language, sure, right? Assign that variable Q, once, and then later you can assign it again. Not true in hardware. In hardware, only a single logic block can assign a signal. So assign a signal in only one always statement or continuous assignment statement. Can't have two logic blocks that are assigning a signal.